This daily lesson rewind is for lesson 5 in chapter 2, percent of change. And we're going to just start by talking about what percent of change is, and then let's break it down and see how we actually do it. A percent of change is a ratio that compares the change in a quantity to the original amount. Now that's a great math definition if you're really good with math, but let's make it simpler. What we're trying to do is we're trying to find how much a number changed and what percent that change is of the original. So it's going to look like this. The percent of change is equal to the amount we changed compared to the original amount. So if you save $25 on a $60 coat, your percent of change is found by taking the $25 you saved and dividing it by the $60 the coat was. So the process is actually pretty simple, but the key to this whole process is understanding that we don't want an amount of change, we truly want a percent of change. So the amount isn't what we're looking for by the end, the percent is what we are looking for. So let's flip and take a look at how we do it. When we find the percent of change, here's our algorithm. Number one, we do find the amount we changed. But remember, we just said that's not the ending point. We find the amount of change, then we divide the amount of change, always by the original. Then we state it as a percent. So a lot of times these algorithms, you might have to rewind the video and come back to it, but let's see it actually in practice so it's easier to remember. So remember, we're looking for amount, division, percent. So amount, division, percent. That's what we're trying to do. So let's take a look at an example. It says find the percent of change in the cost of gasoline from 1970 to 2010. Round to the nearest whole percent if necessary. Now the first thing we want to do is we want to look and say, okay, do we have an increase or a decrease? Well, like the price of most things, if we go ahead 40 years, probably it's more expensive. Everything gets more expensive over time. So we look at this, and the very first thing that we know when we look at this is that the gas increased from $1.30 to $2.95. So we're looking for a percent of increase. Now, back to our algorithm that we just talked about, the very first thing we do is we find the amount that we changed. So if we look at this example, we want to find the amount of change between $1.30 and $2.95. How do we do it? We take the $2.95, that is the price now, we take away what it used to be, and that will give us how much we increased. So now, again, this is not your answer. This is the amount of increase. So we went up $1.65. But remember, our learning objective is to find the percent of increase. Two completely separate ideas. So now that we know the amount, now we can take the amount to find the percent increase. And how is that done? Back to our original ratio, the percent of increase is the original amount, the amount of the increase, the $1.65, divided by the original amount, which is the $1.30. So we're going to have $1.65 over $1.30. When we divide that out, we get 1.27, and remember that's over 100%. So to put it back in a percentage, we move our decimal 2 places to the right, and we get 127%. So the cost of gasoline increased by 127% from 1970 to 2010. So remember, our 3 S's for successes are the setup, the solve, and then the statement. And the statement, just like in science class, should tie back into what the problem asked in the first place. Okay? Let's move on. For this one, it says Yusuf bought a DVD recorder for $280. Now it's on sale for $220. So again, the first thing we look at is we went from $280 down to $220, so it's a percent decrease. Now think back to our algorithm. You can rewind if you need to. Our algorithm said find the amount first. So the amount, 280 minus 220, means we decreased $60. But the question isn't how much did we decrease, it's what percent did we decrease. So now we're going to take that $60, amount of the decrease, and find what percent of the original that $60 is. So 60 divided by our original price of 280 gives us 0.21. And remember, step 3 is state your solution as a percent. So 21/100ths, percents always out of 100, is 21%. So setup, solve, state, we would say the price of the DVD recorder has decreased 21%. Now, percent error works about the same way. The only difference is instead of the amount, it's the amount of error over the actual amount that we got. So we're going to be making predictions, and we find out how far our prediction is off of what the actual numbers are. Now again, the percent of error algorithm, find the amount of error, just like we did before. We want the amount of the error, we divide it by the actual value, and then state it as a percent. So very, very similar. We just have to be careful what number we're dividing by. Let me show you an example. Ahmed wants to practice free throws. He estimates that the distance, so here's the key word, he estimates, so we know we're finding percent error because he's just guessing. He estimates that the distance is 13.5 feet, when in reality it's 15 feet. So he underestimated, and we want to know by what percent, not by how much, but what percent. So now let's take a look at what he did. Same first step, 15 minus his guess. He was off by 1.5 feet, and that's where some students leave their answer. They say, well, he was 1.5 feet off, but that's not what we want. What we want is to know what that 1.5 feet is compared to what it actually is away from the free throw line. So now we're going to take that 1.5 feet and we're going to put it in as the amount of error compared to what it actually was. And we need to know how far off he was from the actual value, not his guess, but the actual value, what it proved to be. And it comes out to be 0.1. So 1/10 is 10 hundredths. 10 hundredths is 10%. So now we hit 3 and we look. The percent error is 10%. And we're good. So again, whether it's percent error or we're looking for percent of change, we always start with the amount. We divide the amount by either what we started with or the actual value, and we always put our answer as a percent. If you need to rewatch this a couple times, that's fine, or if you want to go forward to the homework assistance video, that would be fine too. Good luck.